Hello, and welcome to another Unreal Engine template tutorial. This time we'll be going over the mobile bowling template. We will start off with the level setup. You have several alleys, which are just meshes. You have the pins, which are all blueprints. You have blocking volumes, which don't allow the bowling ball to bounce outside of the alley and the gutter zone. You have a standing zone. This zone is basically there to detect when the pins have fallen over. In the very back there is a mesh here with a physics material that basically absorbs impact so the pins and ball don't bounce back. Very hard to see here, but there is a gutter zone. Let's go to side view. If you look, the gutter zone falls into the actual gutters and in the back pit, the pin area. This is used for detecting when the ball has hit into the gutter or landed at the back, so we can begin checking for the pins and doing our reset procedures. This is what we call the approach zone, which is essentially the ball staging area. We use this for camera math. This note, which will basically have a link to this tutorial video when it's completed. Our actual camera, that is about the gist of it. In our level blueprint, which if you're unsure of how to get to there, is under here. Open level blueprint. Begin play. We collect our camera object, get its start location and start transform. Honestly, this can be simplified down to just using the one transform instead of the start location. This is built on the mobile golf template, so there's some relics of that left. In the tick, we check to see whether or not the bowling ball is still in the approach zone. So you can see if it leaves this approach zone, then we know that the camera needs to begin following the ball down the alleyway, which, as you see, yeah. If it is in the approach zone, then we basically keep the camera static at a given location in rotation and field of view. If it's not in it, then that's when we begin to do a bunch of crazy math here for interpolating. This also could be one node, interpolating the field of view and the camera position and angle. In the content, we have default grid material, which is out of the engine, but it's been stored in here just for convenience of not having engine files. It's used for the texture for the floor. We have our speed trail particle, which, just like the golf one, is this trail here. Not 100% necessary, but just adds some visible motion. We have our meshes. We have our arrow, which is used in the other player controller, our bowling alley mesh, the bowling ball, bowling pin, and then our materials, which are in the wrong folder. We'll have to fix that later. We have our ball physics material, our cushion material, physics material for the back, the floor material, black for the gutters, and the back lower area, I believe. We have a single level, which is the level that we're in. And then we have our blueprints. As a side note, if you decide that you want to fill these other alleyways with pins, do not use the bowling pin blueprint actors, because what will happen is the game is checking for all the pins for resetting and hiding them inside the gutter, or basically in the pit area. So when you have multiples, which I fumbled on these, after a round, when it goes to reset the pins, it's going to detect those not in the approach zone and just clear them out. So you'll lose your pins. So just use the pin mesh if you're going to do that. In the blueprints, we have our approach zone blueprint, which basically on every tick just checks to see if the bowling ball is still inside of it and sets a variable. It's more or less just the collision box. We have the bowling ball itself. In the bowling ball, we have the original transform that we store from where the ball is first spawned. We save that for doing the reset to put it back in the same location. This is the actual event for resetting the ball. We turn off the physics. We set the transform back to the reset transform and then turn the physics back on. We do this that way the physics don't detect the motion, because even if you teleport the physics, sometimes it'll still move a little bit. We clear out whether or not the ball has been bowled or if it's being held, and then the stage location variable. In the tick, we check to see if the ball is being held. If it is being held, then we make the arrow visible. This only applies really for the launch player controller, which we'll get back to. We check the physics linear velocity of the ball itself, and if it's over a certain threshold, we go ahead and make the speed trail visible. If the ball has not been bowled, then we interpolate the stage location. What this is when you are namely the launch control character, you can slide. Let's give an example here. Go ahead and world settings, and we will change it to the launch player. You can slide the ball in the staging area. That is the stage location variable. As you can see, when the ball is being moved around in the staging area, there's no arrow, but as soon as you come out of the staging area of your cursor or your finger, it begins to show the arrow to give an indicator where the launch is going to go. Okay. On the swipe player controller, we still do something similar to this, but you can't move the ball around. It just because it's meant for just swiping. So whenever you touch an area in the staging area, it kind of moves the ball to that general area. Now it doesn't have to be touched in the staging area. You can touch over here. So basically anywhere on the X axis it's going to translate to. This is the event that basically stores the stage location, which is all that's called from the player controllers. Again, the event for storing the whether or not it's being held. The set angle, again through the player controllers, whenever you're adjusting your positioning, like you see the arrow turning, that's all part of that. Here we're adjusting the ball rotation and the arrow rotation, basically the whole actor's rotation based on that angle, and we're adjusting the scale of the arrow to match the intensity of the throw. Here we're applying an impulse to actually launch the ball down the alleyway. We turn on the physics. This guarantees that the physics are on, and then we add the impulse based on the direction that it was being fired, which is all controlled through the player controller blueprint. We set the bold variable boolean. We set the bold boolean to true, and this more or less makes it where you can't interact with the ball anymore. And that's basically the ball itself. In the bowling game mode, this is where we do all of our game logic checks. At the beginning of the game, it collects the gutter zone reference, the bowling ball reference, and the standing zone reference. Each tick, it checks to see if the ball is in the gutter box, that collision zone that we'd mentioned. If it's in that area, it goes ahead and gives a 2-second delay. Just the ball has a chance to finish moving pins. After that delay, it checks for all the pins, collects them, and then determines in the standing zone how many pins are remaining. If there's no pins remaining, then we've knocked down all the pins. We print a string saying that we've done that. And we go through each of the pins that we gathered here, and we reset them. So we put them back to their beginning location. And then we reset the ball. If there's still pins left, we print that there's still pins standing. We reset the ball, and then we go through each of the pins, and we check to see if the pins are in the standing zone. If they are in fact not in the standing zone, then we just hide the pin. So we'll get back to that shortly. Under the bowling pin, we store the reset transform. We've added a small delay here because sometimes when the game's first booting, it'll set the transform on the begin play when the pins aren't completely where they're supposed to be in the game. So we add a small delay to ensure that we get it. This is the hide the pin event. We basically take the static mesh of the bowling pin, we turn off the physics on it, and then we just hide it kind of below the floor. This is the reset the pin. Again, we turn off the physics. We change the transform back to the original reset transformation. We change both the actor and the world transform of the bowling pin and the actor, just to make sure. So the reason we do this is when you have an actor that's has a physics object inside of it, the physics object itself can get way off from the source position of the actual blueprint of the actor itself. And if you just reset just the actor, the pin itself could have still been off in nowhere land. So you reset both of them back to the same location so they're zeroed back out. And then we re-enable the physics. This is old, no longer used, so we'll need to clear that out. I'll need to fix that later. That is basically the pin. Gutter zone, again, is just a box collision that we set a variable if it detects that the ball is inside the box. Alright, so we'll go to the standing pin zone. Again, it does nothing because we're doing all that logic in the actual game mode. We'll start with the swipe controller. Begin play, we're showing the mouse cursor. This is just for desktop use, namely for testing. After that, we have our input touch. On pressed, we get the bowling ball reference. Because in the swipe controller, we are not required to actually physically touch the bowling ball to select where it's going to fire. As you've seen before, wherever you touch, it kind of moves the ball to that location. So we get the reference to the ball, store it, and then we store where the actual touch point was, and then we update the stage location based on that. We tell the ball to update with that new touch point. Skip over here to, well, I guess we can continue after released. We verify that we do in fact still have a proper bowling ball reference, because the ball has blipped out of existence, so we don't want to cause crashes. We tell it to clear that it's being held, and then we apply the impulse to it with that direction vector that we talked about before, a preset multiplier, and then we clear the reference to the bowling ball. In the onMoved, this one's a little more necessary. In the onMoved, we check to verify that the location of the touch for the finger is not zeroed out, because what will happen is when you release, there will no longer be input there. It'll no longer actually have a touch location, but it'll still trigger it. And when it does that, it can break your direction math. So we check that that's not zeroed. If it's not zeroed, then we go ahead and take the initial pointer location and we subtract that from the new location and we convert that into a direction vector. We clear out the z-axis of the vector because we don't want any kind of elevation in our firing of the ball. We just want it to be on the 2D direction. That is the swipe player controller. It's fairly simple. There's things that we're not doing here because we're trying to keep it super simple. We could store a start time, a float in milliseconds in the game time of when the touch was done, and then compare that to when it was released, and then actually apply a number to the multiplier here to give us more accurate swipe intensity, like an actual velocity on the swipe. But with the bowling game, you want to have a limited minimum and a limited maximum, because if you have too little velocity, the ball takes forever to get to the end, and it may even go stagnant. If it has too much velocity, then you're going to see it smack the pins insanely hard to where everything's just bouncing everywhere. So we kind of just control it by not doing it that way. So the way this thing actually works is it's creating a velocity based off of the drag length versus a drag speed, swipe speed. The more complicated player controller is the launch player controller, but not super complicated. Again, begin play, we turn on the cursor just so we can see it. We don't do anything in pressed. The reason being is a long while back I came to the conclusion that it's more natural for a player to drag over an object they want to touch versus just tapping it and hitting it. So if you have a little bit of motion that you can get the object with, it just feels more natural. So in on moved, that's when the input is scrolled, we check if there's a bowling ball reference. If there is not one, then we check for where the player is touching, and if there's an actor that's underneath where it's touching, we check to see if it's a bowling ball. If it is in fact a bowling ball, then we go ahead, we check first that it's not been bowled, because we don't want them to be able to grab the ball as it's rolling down the alleyway. If it has, we clear the reference. If it hasn't been bowled, then we apply the reference and we tell the ball that it's been grabbed. Okay. If in unmoved, if it is, we do have an actual proper bowling ball reference, we verify whether or not the touch location is within that staging area. Now we could do this two ways. One would be to see if the touch is actually overlapping that approach area. That would be fine, but I knew the math of the actual axis of the Y where the touch is at, so I just went with that. We verify if it's in the staging area. If it's greater than this point, then that means it's not in the staging area. If it's lower than this, then it's in the staging area. Okay, so if we're in the staging area, we basically update the ball to the new stage location. We just store that stage location like we were talking about before, and we clear it being grabbed. This way the arrow is not being visible. If it's outside of the staging area, your finger, the touch is, then that means that we're trying to actually aim. So when we do that, we show the arrow. We verify that our touch input is not zeroing out like we had talked about in the previous one. If it's not zeroing out, then we go ahead, create our angle vector, doing the same kind of math before. We take the ball location and we take the touch location, create our vector, we set the angle, we store a direction vector. On release, We verify we still have a bowling ball reference. If we do, we're good to go. We clear it being grabbed. We fire that direction vector with an impulse, and then we clear the reference. That's pretty much it. This blueprint is very much like the mobile golf controller, and the fact that you have to drag around to create a direction. That is basically the entirety of this template. Not much to it. It doesn't actually do scoring. You can actually bowl unlimitedly. You can just keep chucking the ball. That would be 2. That'd be 3. There's number 4. Number 5. So I mean, it just keeps going because we're not actually checking for a maximum amount of bowls. We're just going until the pins have been cleared, and then, ooh, look at you. We're going until the pins are cleared, and then resetting the pins and going over. So it doesn't really have a full bowling game logic. It just gives you the basis of starting one. So you could do your own scoring to create your own modified version of bowling if you wanted. Thank you for checking out this template. If you have any questions, you can comment here, email directly, or on Gumroad. Thank you again.